So this is a video that's going to be working out some of these problems. You're going to want to be using your notes that you just took on the previous video about ratios and proportions, but here we're going to actually be working hands-on to solve them. So this is going to be number 3 from your homework set, and given that A over B is equal to C over D, we're trying to decide, is it a true statement if I were to say B A is equal to D C. So the idea is you have that cross multiplication, or you have that cross product property, which states that as long as you have proportions, you do know that the cross numbers are going to be equal. So I am going to just simply state from this I could determine that A times D, that cross product, is equal to B times C. Do I have that going on here? And basically, no, I can't even change these around at all. This number 3 is no, not a true statement, not true. Number 18, so we're going to be using that cross product property a lot. For example, number 18, we're going to be solving 4 over 2x is equal to 7 over 3. Keep in mind there could be stories behind these. We don't know them. But there are possibly some potential stories behind these. So looking at this, what I am going to be using is that cross product property. We had the other things available to us, equivalent fractions, but you can't really say, I mean, it's really hard to tell how to do it with this. You could ask yourself 4 times what equals 7, and then whatever that is, you could be setting up equation 2x times something is equal to 3 and then solving for that. But otherwise we have, by the way, this is a 3. Otherwise we have kind of a shortcut with this cross product multiplication. 4 times 3 is equal to 7 times 2x. So I used the cross product property right there because it was a proportion. The cross products are the same. These are going to be equal to each other. So I've set up that equation. So now I just need to simplify everything that I can. In this case, 4 times 3 is 12. 7 times 2 is 14 times x. That's a times. Okay, and now we just need to solve for that x, so divide both sides by 14 to undo the multiplication of 14, and what we're going to get is x is equal to, reduce this if you can, but you can leave it as a fraction. 2 goes into 12, 2 also goes into 14, so 6/7 is our answer. So it's a little goofy, but you want to check your work, so I'm going to check it here. We have 4 over 2 times 6/7 equals 7 over 3. And if I simplified this, I'm going to be getting 4 times 12 over 7. So that's what's on the bottom, because I would have just multiplied those straight across. We have 7 over 3. I'm going to simplify this fraction. I have 4 divided by 12/7. So instead on this side I'm just going to write it as 4 times 7/12. So remember, if you ever have division like this, you can always rewrite it as multiplication. So that's what I've done. I've switched this division bar to multiplication and switched this thing that I'm dividing by to its reciprocal. Equals 7 over 3. So now if I were to reduce this, keep in mind that 4 is 4 over 1, so this is going to reduce by 4, this is going to reduce by 4. We're going to get 1 over 1 times 7. Oops, sorry, this is a little messy, I'll get better. 7 over, and then what is that? 3, because 12 divided by 4 is 3, equals 7 over 3. True statement, so that checks out, we're done. This is our final answer. Alright, now I'm going to present one that's a little bit tricky. We're going to look at number 26. Number 26 looks like this. 5 over 2y is equal to 7 over y minus 3. So we need to solve this proportion. Keep in mind we have these two variables that we're trying to solve for. So here I am going to use my cross product property first to start me out. So I'll try to write neater this time. 5 times y minus 3 is equal to 2y times 7. So I'm going to start simplifying this as much as possible. I'm going to distribute this, and then I'm going to multiply the numbers that I have. But what I would like to bring you up, and as a reminder, so I'm sorry, there is a few extra notes that I might have you take here, or that you should write down in your notes. So here is a list that I would like to have you write in your notes. And what this is it's kind of the step-by-step process on how you solve these more complex equations. So I always suggest changing subtraction into addition. You don't have to do that, but it's a suggestion, just because subtraction can really confuse people and signs get messed up a lot. So that is a big suggestion that I tend to do. Number one, the first step is to get rid of parentheses if there are any parentheses through distribution. Number two, if there are variable terms on both sides of the equal side, you're going to get one side rid of the variable terms. So if you have, for example, 3x on one side, 2x on the other, what you're going to want to do is, for example, focus on getting 2x off of one of the sides. But don't forget, whatever you do to one side, you have to do it to the other. 3, simplify both sides of the equal sign. So we want to make sure everything's simplified as much as we can go. And then we're looking at 4, reverse PEMDAS once again. So in other words, SAD MEP, if you so choose to look at it that way. SAD MEP. Okay, so I'm going to take these down with us. So keep in mind, this is what we were trying to solve. I'm going to put this checklist kind of right with us so that we can go and use this all the way. So first of all, I'm going to change subtraction into addition. So I'm going to change this so it's 5 times y plus negative 3. So to change subtraction into addition, it's the same thing as adding, but then just the negative value of what you were subtracting before. So there we have that, and then equals 2y times 7. So I am done with this first step. I'm going to check that off. First step that I'm going to do is see if there's any parentheses. We're going to want to get rid of those because we want to get rid of this family or this grouping. So we're going to distribute this 5 so that it's going to be multiplied by everyone in this group, because 5 wants to be multiplied not just by the y but also by this negative 3 over here. So it's going to be 5y plus negative 5 times, or I'm sorry, positive 5 times negative 3 is going to be negative 15. Okay, so I'm going to go ahead and check this off because I'm done. And then number 2, if there are variable terms on both sides of the equal sign, get rid of one of the variable terms. So what you could do, so sorry, maybe I should say simplify both sides first. We're going to switch these actually. There we go. We're going to simplify both sides. So I think that would maybe be better here. So sorry about that. We're going to go ahead and simplify this. These right here, these numbers can be multiplied together. Okay, so these right here are not like terms, so don't forget what it means to simplify means to combine any like terms that you can. And when we're adding or subtracting terms, we have to be very careful that they're like terms. So this side actually stays exactly as it is. And this side over here though, we could multiply because remember, order doesn't matter when we're multiplying. You could get 14y. Okay, check this off. Alright, so if there are variable terms on both sides of the equal, now what we can do is do that. I think the easiest thing to do is get this 5y off of this side because it's smaller. So I'm going to subtract 5y from here. That will get rid of that term, but don't forget, in order to maintain this equality, we have to also do it on that side. So to keep it balanced and keep it fair, whatever you do to one side, you have to do the other. Just be careful with your algebra. So the final step that we're going to do here is reverse order of PEMDAS. You want to locate the variable that you're solving for and get it by itself. So you see that multiplication being done onto that y, we want to undo it. So we're going to divide both sides by 9. So we're going to get y is equal to negative 15/9. And if you do get fractions, simplify them. Okay, so y in the end, sorry, yellow is kind of a bad color, but negative 5 over 3. There is our answer. That's it.